brave audience, thank you for being here bright and early at 8:30, especially after last night. So we appreciate you being here. Today we're going to be speaking all about distributed training on Amazon SageMaker. I'm Anirudh Vishwanathan. I'm a senior product manager with the SageMaker HyperPod team. I'm here with my colleagues, and we've also got a special partner introducing Sanjay. So Sanjay, my colleague.
Hey folks, my name is Sanjay Doreraj. I'm a software development manager at Amazon SageMaker, and I'm super excited to be here to talk to you about this new feature that we're launching, HyperPod recipes.
And our special guest.
Hi everyone, I'm Tony. I'm an AI scientist at Salesforce working in generative AI, and have been using SageMaker and working with them, and super excited to tell you about some of the things we've done at Salesforce using SageMaker.
Sounds good. Thanks, Tony. Thanks, Sanjay. So with that, let's dive straight in. So when thinking about why you're here, I'm going to start with this. This chart out here, it's data from Epoch AI, which is essentially a non-profit which authors the Stanford AI report, and it tracks essentially development in the foundational model space. And if you look at data going back from 2010 right up to where we are today, the amount of training compute for foundational models is growing between 4 to 5 times a year, which means that every 6 months, the amount of compute's essentially doubling. So we've gone essentially from petaflops back in 2010 to, I think it's thousands of yotaflops. That's the term that's used. And I was looking up what the powers of 10 are, and the specific words are there. But essentially, there's an explosion in the amount of compute that's needed for these models. So we've got larger models that are going from billions of parameters to now something that's trillions of parameters. Along with this, the amount of data that's being used by this model is also roughly doubling every 8 months. And with the amount of training data growing at this rapid pace, there are even concerns around, will infinite scale data continue to scale, or will we run out of data eventually? So there are larger models, there is more data. Putting this together, it means that the amount of time it takes to market will also increase. And what we've been seeing is that it roughly increases year over year. So you've got larger models, more data, and a longer time to train. Putting this together, it means that essentially there are unique challenges when it comes to foundational model training. Essentially, these models span thousands of accelerator devices like GPUs or Trainium devices, and managing the infrastructure in an efficient and easy way can be challenging for customers. This is heavy lifting that we'd like to take care of for you. The second is the stability of infrastructure. Quite often, given the distributed training of these workloads, you have multiple devices that are communicating with each other. You have things like GPU failures, hardware failures, and so on. And you need an infrastructure that's stable and resilient for your training. And lastly, given the scale of these models and the time to train, you're looking at workloads that run maybe a few days to workloads that run several months, depending on the scale of the data that you're training with and the size of the model, which means you want to squeeze out every inch of performance improvement that you can do with your training workload. That's why we built Amazon SageMaker HyperPod. So last year at reInvent, we announced HyperPod, which lets you scale your training workloads efficiently across thousands of accelerator devices. HyperPod essentially is designed for scale. It offers a resilient training environment that accelerates your model training by up to 40%. And the idea is that it also offers advanced observability tools that let you have granular control over your cluster environment. HyperPod is used across a variety of customers, from startups like Luma AI and Articulate to enterprise customers like Salesforce. And you'll hear Tony speaking about his experience with HyperPod later today. So let's step back and think about how to optimize the distributed training stack. This diagram here essentially shows what the breakdown of a distributed training stack that's typically built on the open source would look like. Essentially, at the lowest layer, which is down here, you've got the device. This essentially is the accelerator device, which might be a GPU or a Trainium-based device. Along with the device, you've got the device's kernel drivers. Above it, essentially are things like Nickel, which is the NVIDIA CUDA communication layer. And the idea is that all of these devices need to be wired together, ideally on the same rack and the same spline, and you need to have efficient communication across these devices as they exchange information about the current model training state. That's where the network and hardware programming all come in to let these accelerator devices efficiently talk to each other and exchange and share information. Above this are essentially the distributed training frameworks. These are the ones that you might be more familiar with. These are things like PyTorch, Nemo, Megatron, and so on. And the idea is that the distributed training framework lets you easily run your model training loop, and you have different layers of abstraction depending on where and how much granular control you'd like to have over your training loop. So we looked at this and essentially said, let's think about ways to optimize the training stack. So we offer two key optimizations at this point in time. The first is we have SageMaker Model Parallelism, which is a fork of PyTorch, which offers enhancements for your training libraries. And we also offer HyperPod recipes that we announced at this reInvent. So let's first look at the SageMaker Model Parallelism library. The idea with SageMaker Model Parallelism is that it's a PyTorch fork and essentially offers a set of composable training techniques that you can build and plug and play together. So when you think about the developments in these open source frameworks, it's typically as follows. You might have essentially tensor parallelism that's best in class with Nemo Megatron, but you want to use this tensor parallelism in your workload with PyTorch FSDP. However, for you to do that, essentially you have to manually integrate these components across different frameworks. This is undifferentiated heavy lifting because it doesn't really focus on your differentiated model training or your data, but it's just integration across different frameworks. So SageMaker Model Parallel essentially helps you access composable tensor parallelism with PyTorch FSDP, and you don't need to do any further integration manually. Similarly, it also offers capabilities of context parallelism, including support for 128K context length with the Llama model that you can use with PyTorch FSDP. It also offers things like FP8 training, and the idea essentially is that you can pick and choose sort of best-in-class capabilities across different frameworks and still use it with the core PyTorch distributed training offerings. Other optimizations that we've made as part of this package is essentially about asynchronous checkpointing. Before I dive into checkpointing, let me just walk you through why we need checkpointing when training workloads. So the idea with checkpointing is essentially you want to periodically save your model state. The model that you have is so large that it typically doesn't fit on one GPU, which means you need to split it across multiple GPUs or accelerator devices, and also split the optimizer state across different accelerator devices. Now, as your training progresses, you might have challenges such as a GPU burns out or there's a hardware failure. There might be a software glitch that causes your training to fail. At this point in time, instead of stopping everything and rerunning training from scratch, what you'd like to do is essentially try and start training from the last save checkpoint, which means that in an ideal world, you want to checkpoint as frequently as possible. But the trade-off here is that if you checkpoint too frequently across thousands of devices, your GPUs are essentially waiting and you're wasting precious cycles on GPU compute. So the question becomes, how do you accelerate your training by optimizing checkpointing? And what we've built essentially is asynchronous checkpointing, where as the GPU is running training, there's a separate worker that's writing these checkpoints to S3. And we've also made optimizations under the hood around essentially a smarter metadata caching system. And this checkpointing capability is directly compatible with the PyTorch native DCP API. So you have no additional code changes that you would need as part of using these improved checkpointing capabilities. So the idea is that all of these optimizations, from composable parallelism techniques to advanced checkpointing capability, help you squeeze out your model training performance. So we've spoken through essentially the layers of the framework. SageMaker Model Parallel Library essentially helps you optimize the building blocks. These are the parallelization techniques as well as capabilities like checkpointing. That being said, we said, why stop there? Let's also think about how to abstract away the complexity from running large-scale training workloads with the most popular foundational models. And at this reInvent, we announced Amazon SageMaker HyperPod recipes that essentially make it easier for customers to train large publicly available models like Llama 3.1 in a really easy manner. I'd like to invite Sanjay up on the stage here to speak about the recipes, and we'll dive further in.
All right. Okay. Hey guys. Hey folks. Thanks. Thank you, Anirudh. My name is Sanjay Doreraj, and I lead the team that built SageMaker HyperPod recipes. It's a pleasure for me to talk about the launch of HyperPod recipes, which is a game changer that we feel for customers looking to pre-train and fine-tune large language models on SageMaker infrastructure, especially on SageMaker HyperPod. It reduces the time that you're going to spend getting started with pre-training and fine-tuning down to a few minutes. So our main goal is to help you, right, get started with pre-training and fine-tuning almost immediately, right? And that is where we see the power of HyperPod recipes. Before we get started, I'd like to get a quick show of hands just to understand you better. How many of you are currently pre-training and fine-tuning LLMs? Okay, that's a few of you. How many of you are using SageMaker infrastructure to pre-train and fine-tune? Nice, about the same folks. Cool, thank you. And how many of you are planning to start LLM training or fine-tuning over the next 6 months? Great, I see a lot more, pretty much all of you. That's really cool. So I think I have some good news for all of you today as we go about, spending a little bit more time talking about how HyperPod recipes can benefit you. So as Anirudh pointed out, SageMaker HyperPod is infrastructure that's provided through AWS that's optimized for large-scale distributed training and fine-tuning. Now, it has some really powerful features like automated recovery from failure to ensure that customers, you have a highly performant and highly resilient training infrastructure, right? While it provides this optimized infrastructure, there's still the question of how you, as a machine learning developer or scientist, actually get started with that training. For example, the first thing you have to do is actually find the model, determine which model you want to use. Then you spend hours sometimes, and sometimes even days, trying to figure out the right framework that you want to pick, right? Whether it's Nemo or PyTorch or a combination of the two. And then you spend a lot of time trying to optimize the parameters in order to make sure that you have the right model configuration. And then finally you get started with your training and fine-tuning, right? So this is a lot of work, and this is where we see a lot of companies struggle, right? I mean, some of these are complex configurations that can take days and weeks to get set up. Sometimes companies even give up on foundational model training and fine-tuning because of the challenges that you see here. To kind of put things in perspective, right? When we talk about pre-training or fine-tuning large language models, there's over 70 plus pre-training parameters that you need to configure, and over 100 plus fine-tuning parameters that you need to configure. It is a lot. If you think about the permutations, they just add up to thousands of combinations that you could potentially run in order to figure out the best model configuration. And each parameter choice can in turn cause changes to other parameters. And the other issue that we have is that as new models keep getting added all the time, right, you find that the time that you're taking establishing these parameters, right, could be so long that you're now switching to another model, and now you're really always chasing the next best model, but never really getting started with your pre-training and fine-tuning, which is another reason why we've heard from customers where sometimes companies don't want to pursue, right, teams that are actually in this business of doing pre-training and fine-tuning. You may end up with your default choices may be suboptimal, leads to cost overruns and missed deadlines and reduced productivity. I'm guessing this is a problem that some of you are are encountering where you are, right? This is where SageMaker HyperPod recipes comes to the rescue. With SageMaker HyperPod recipes, what we have is a set of optimized configurations for pre-training and fine-tuning large language models on AWS SageMaker infrastructure. We've arrived at these configurations through extensive benchmarking carried out by our team at AWS. With a single line of code, you can now pre-train or fine-tune popular open source models like Llama, Mistral, Mixtral on your favorite AWS HyperPod cluster, Slurm, Kubernetes, or SageMaker training jobs. The recipes take care of creating the entire training loop for you and starting the training job as well. So you really don't have to do anything beyond that, right? This is something that's been, we're giving you the best in class configuration to get started with your training. So with a single line of code, you can seamlessly switch between GPU and Trainium workloads to take even more advantage of the price performance advantage that Trainium brings. Users can customize recipes as well if you want for your own custom models that you're trying to build. We have options where you can even extend the recipes and the models that we're giving to create your own definitions and still work within the HyperPod recipe framework. So getting started with HyperPod recipes is really simple. Again, the reason why we have this feature is so that you get started with pre-training and fine-tuning immediately, right? We want to take away the pain of optimizing your model configuration. We want to take that away from you, right? So as new models come in, you're immediately able to experiment and start running your training and fine-tuning. All you got to do with HyperPod recipes is you select a model training and fine-tuning recipe on open source GitHub, right, where we've open sourced it with Apache 2.0 license. You then set up your AWS prerequisites, right? You have your configuration, your credentials, your resource limits, whether you're using SageMaker HyperPod or whether you're using SageMaker training jobs, right? And the cluster you're trying to use, and then you run the recipe. And I'll show you in a few slides exactly how that's done. So this is essentially where you can find SageMaker HyperPod recipes on GitHub. This is Apache 2.0 licensed. I'd love you to take a picture, and you can then quickly go and look at the README file that's there to learn more. So this is what you're going to find once you get there. So essentially, there's a README page that walks you through in detail exactly how this works, right? What recipes are available, what features are supported, and all of that. We support over 30 recipes at this time. Like I said, across Llama, we support Llama 3.1, Llama 3.2. Fine-tuning, for example, you can go and right away, you can go and start fine-tuning Llama 3.1 405B with 128K context length, right? So this is something that we've arrived at through a lot of work on our side, and we're really happy to be able to share that with you so you can get started. It's built on Nemo, so for those of you who are familiar with Nemo, right, this will be something that you're going to be really, really comfortable with. And the fact that it's open source means that everything is going to be much more accessible to you. Even if you don't have an AWS account at this point, you can go and check it out and see what's there. Optimized for GPU, optimized for Trainium, native Nemo support, and as well as custom model support. Before we, as we sort of get into a little bit more, so I want to point out a few important folders that are present in GitHub. So just so you're more familiar with this, the first folder is the launcher scripts folder that you see up there. So that contains pre-configured bash scripts that we've written that invokes our Nemo style launcher with environment variable setup. So once again, the idea is to try to make it even more easier for you to get started, right? And you can always go and modify these bash scripts you want and let them point to your own environment specific configurations. Then you have the recipes collection folder that contains all the recipes for fine-tuning and pre-training. It's written using the Hydra-based format with YAML. So once again, very familiar sort of interfaces. And then there's a main.py file, which for those of you who are familiar with the Nemo launcher, you'll find, I'm sure that this will be something that is you're going to be really comfortable with when you use it. It's sort of built very similar to that. And just to kind of, and finally, there's a Docker container or an enroot based file system that we've also built that contains a lot of the dependencies that HyperPod recipes use. So as part of actually using HyperPod recipes, you would actually also pull in this container so that and the container has a lot of the logic to actually generate the training loop. You can always place your own container, your own custom container if you want, but hopefully you would not need to use that. Okay, so this is basically a look at what a recipe would look like. So as you can see, in this particular case, right, we provide information about the recipe information. We provide the model type, whether it's coming from Hugging Face or somewhere else. You can configure your trainer. Again, a lot of these are pre-configured for you, so you don't have to do this, but you can certainly change the accelerator. That's what I meant when I said a single line of code. You can switch between GPU to Trainium, right? So we make it really easy for you with these pre-configured recipes for you to get started right away. Here's an example of your cluster configuration file where, in case you're using Slurm, for example, this is the Slurm cluster configuration. You can go and add your specific configuration here to make it work for your infrastructure. You can see there's a job name prefix that we've added, and there's also an interesting thing I want to point out. There's on line number 6, it says Slurm create submission file only. In case you didn't want to, like with the recipes, you literally run the command and it's going to launch the job for you, right? So you don't really have to do anything after that. But in case you wanted to inspect the Slurm command before you actually run it, you can always set that to true, and that will actually generate the Slurm command for you that you can then run manually. So once again, a lot of added work that we're doing on your behalf to make it easier for you to do training. And this here is another config.yaml file that sort of brings a lot of this together. It's a top-level file where you can specify your cluster type, you specify the recipe, and other parameters. You can see at the bottom where you can also provide your own container if you want. You can also provide your own GitHub repo in case you decide to fork what we have and decide to provide your own repo. You can provide that as well. So just infinite customization. Hopefully you won't need to use it, but if you want to customize, you have that feature as well. Next, I want to talk about the commands that you would actually run. Like, what does it look like when you're actually running the commands to execute this? So if you're using Slurm, we would recommend that you use our launcher scripts because it's already there, right? There's really no need for you to do anything more. You just go to the launcher scripts folder, you go into the model directory, and you pick the appropriate launcher script, and you just launch your training, and it should fire the job off on the corresponding cluster. Now, if you're using Kubernetes, we recommend that you use the HyperPod CLI. So HyperPod CLI is another open source repository that has commands like HyperPod start job. Makes it easy for you to run commands on HyperPod. So you can actually pass in a recipe as a parameter to HyperPod start job to get you started with the training. Again, single line, really simple. And once again, you can always default to the Nemo style launcher in case you're just something that you're more comfortable with, right? And then if you want to run training on SageMaker training jobs, then all you have to do is modify when you generate your estimator, you pass in the recipe as a parameter to the training recipe parameter that just got added as part of the HyperPod recipes launch. So this happened about a couple of days back during the reInvent announcement. We launched a PySDK release as well. That in the SageMaker PySDK release that incorporates a new parameter called the training recipe parameter to the PySDK estimator that allows you to run HyperPod recipes as part of your as part of your SageMaker training job as well. All right, so let's talk about how all of this comes together in terms of how does this work. How do we actually make all of this work in the back end? It's fairly simple, really. So once you invoke your command, right, whether you're using HyperPod CLI, using SageMaker Python SDK, eventually we're going to invoke the Nemo style launcher at some point, right? So Nemo Style Launcher is sort of like the backbone on which we built this. And then we built these abstractions on top, right? But we invoke the Nemo Style Launcher. First step we do is we parse the configuration to understand what it is you're trying to do. Now, if you are running on SageMaker HyperPod with GPU, then we will invoke the corresponding code that is used to generate the training loop for GPU. For Neuron, we invoke the Neuron distributed training toolkit, so that because we kind of leverage recipes that are already pre-built over there. In the case of NVIDIA Nemo, you can actually pass in an NVIDIA Nemo recipe directly to this particular framework, and it will accept it. And then you can bring your own custom models as well if you like. So once you've done that, and we've built the training loop depending on the particular your requirement, we launch the job on the appropriate cluster, whether it's Slurm, HyperPod, or Kubernetes, or training jobs. So essentially what you're getting is that with a single command, you can now select from a library of over 30 recipes. You can choose the cluster you would like to use, you can create the training job, and you can start the job on your favorite HyperPod cluster or on SageMaker training jobs. So I'm really hoping that you're going to use this feature. If you head on to the documentation page, the link that's on top, we have extensive tutorials that walk you through step by step how to use this. So I would love for you to check that out as well. So happy pre-training and fine-tuning. If you have any specific requests, you can meet us outside after the talk. We'd love to hear from you. With that, I'd like to hand it over to Tony from Salesforce to talk about their experience.
Well, thank you, Sanjay, and thank you all for having me. So I will give a brief interlude about Salesforce AI research, and then we'll bring it right back to HyperPod. So what do? There are three main activities that we engage in. We're Salesforce's AI research org, so we do foundational research and development. That's pushing forward the state-of-the-art AI for enterprise use cases, spanning all the way from academic research to customer incubation, where we work closely with our customers. That's a lot of like pathfinding, feedback. How can we integrate cutting-edge AI into the highest value use cases for enterprise? And then finally, product innovation. So how do we incorporate our R&D on the AI side and our pathfinding and technologies from customer incubation into generally available features across all of our products and platforms? So at Salesforce AI, we've been big users of SageMaker for years. This year, we've started our journey with HyperPod. And the way I would describe it in one sentence is a supercomputer at our fingertips. Really, it's a managed supercomputer at our fingertips, so it's even better. And let me pause for a moment and just kind of motivate why we're really excited to use HyperPod at Salesforce. And I think this chart can help explain a couple of key trends in the industry. So if you just take a moment, you can look at the orange trend line. That is the score of the MMLU benchmark, which is kind of like a multifaceted general language understanding benchmark for generative AI models that kind of captures multiple aspects of natural language understanding and really higher level kind of academic style question answering. And so as you can see, the orange line in 2023, there was like a big jump, right? That was kind of like the GPT-4 moment where GPT-4 really unlocked a lot of use cases and a lot of excitement. And that's reflected here by that jump. And then we can kind of see this blue line, which is like the open source models. And back in 2023 and the start of 2024, it was kind of coming along, like Llama 1, Llama 2, so on and so forth. It was grinding on, but it was kind of still a big gap, right? At the start of 2024, at the start of this year, we still had a very large gap between the closed source and the open source models. And what we saw happen over the past 12 months is that gap has shrunk. And so from the enterprise perspective, where we build products that use this AI, this basically is a shift where now we can take frontier and state-of-the-art models and actually begin to train and fine-tune these and specialize them and bring even more reliability and better improvement for our use cases. And so I think this really helps kind of set the stage for why you might start to think about using HyperPod. So I'll briefly kind of tell you about some of the recipes we've been using on HyperPod. That was one of the key releases that's come out over this reInvent. One thing we really liked is the ability to compose the different training stacks, and in particular, FSTP with context parallelism with low rank adaptation, or LoRa. That's actually a unique feature set that is available to us as part of HyperPod recipes and not in other frameworks. And this really has saved significant work. So one thing we can do with this is fine-tune Llama 3.1 405B at full 128K context using just 4 nodes, and 1 node if you quantize. And this is actually a big deal. There was a colleague of mine, another researcher, that needed a long context use case, and like went off for a week and did all this kind of like grunt work to like integrate the frameworks and get context parallel and basically get like long context. And then you ask him like, okay, like how big is the model? 9 billion parameters. And then you ask yourself, well, how many weeks would it have taken for to get to 405B? So clearly we're very happy that we get this out of the box, ready to go at such large scale, the largest publicly available model. So I'll shift gears a little bit and now tell you about the fruits of our labor. So I'll tell you about some of the cool models we've been working on at Salesforce AI as an entire organization. All of these were trained on HyperPod, and fortunately it's just a subset of the great models we have, both on HyperPod and at large, but hopefully they'll give you a sense of some of the awesome work we've been doing in partnership with SageMaker and HyperPod. So Agentforce is our flagship AI product suite that was released this year. And one model that goes into that is XGen Sales LLM. So this is a proprietary sales-focused large language model. And this has key features such as call summarization, customer profiling, contact enrichment, and pipeline tracking. And users can like interactively use it for various things that I'll describe. I think one key metric to highlight about this model is that the summaries, the call summarization that were generated by this AI in blind tests were actually more likely to be favored than human-generated summaries. So pay attention to this, if you would please, call transcript. So what this is showing is essentially like a user with a salesperson and a customer, and they're having a conversation. So it's like a recorded transcript you might have from a sales call. And on the right-hand side, you can see generated output by the AI. So we've got the customer impression, call summary, next steps. And as a user of this, you can go and highlight a portion of the AI-generated summary, and then the AI will actually, in the call transcript, show you like this is like the supporting raw evidence for that part of my generation. And so that's something that like by leveraging in-house technology and custom fine-tuning, we're able to produce that product innovation. So this is planned to integrate broadly into Agentforce. It's already live in Agentforce with customer pilots that are currently underway. So I'll shift gears a little bit now and tell you about RAGforce. So you may have heard about retrieval augmented generation. I'll briefly cover it in case you haven't. But you can essentially think of it as combining search and retrieval with generative language modeling. And so more concretely, what you do is when the user asks a question, you run some kind of search. It could be semantic retrieval, semantic search, could be keyword, could be hybrid search. And then you take those search results and you feed them into the context of your model. So then the model can apply what's called in-context learning to basically apply those articles to help it generate the right answer to the user query. And this is kind of one of those things where it works great in demos, but in practice, a lot of things can go wrong. So one key pain point we've noticed by working with enterprise customers in the RAG use case is that the quality heavily depends on like the document hygiene. And so in practice, many of your enterprise documents have conflicting versions, or this is a big one, outdated info. How many Google Docs and Quip Docs do we have flying around that are from like 8 months ago, where what they're saying is like totally dated, right? Even inconsistent formatting across documents can sometimes confuse models. And so, how can we actually improve our performance for this use case is something that is of interest and of value for the enterprise. And if you drill down, you ask yourself, how should models handle prioritization of information given like the rich metadata that exists with these documents in the enterprise? So to give a concrete example of this, maybe if you want to tag this is like the official document for this team or this org, maybe that takes priority over a draft of this document, maybe like the next quarter plan. But maybe you want to have like a date, right? So maybe if the official document is more than 6 months stale, we actually should deprioritize that. And so how can you take an AI and have it follow these rules and actually have it be contextually faithful to those rules? Well, that is one of the things that we've worked on at Salesforce Research. So we trained a contextual LLM at only 9 billion parameters to basically maximize this concept of contextual faithfulness. So we want to minimize hallucinations and then also be able to have the user provide in natural language complex prioritization rules that the LLM will then apply to the input document sets. And for this particular kind of use case of contextual faithfulness, we found that just this 9 billion parameter model that was fine-tuned on HyperPod is able to outperform much larger models and achieve state-of-the-art performance on RAG benchmarks. So now we're going to drill down even more, take a deep dive into RAG and retrieval systems, so with reranking. And so in case you haven't heard of reranking, it's oftentimes kind of buried into like the retrieval part of the process, but it's actually a very important component, and it makes a really big difference in the quality of your retrieved results. You can think of a re-ranker, when people talk about like a re-ranker, a re-ranking model, it's basically an AI that is like specialized at quickly going through vast numbers of documents, trying to pick out the ones that are relevant to a particular user query or question. And so if you look at the flow diagram, we've got the user query, and then we've got the knowledge base of documents, and then we've got some retriever that fetches them. So maybe that's an embeddings, maybe that's like a keyword search. Then we take those results that are already have gone through this filtering retrieval kind of phase. Then we pass them to a re-ranking phase where the re-ranker then looks at these initial results and then can reorder them based on how relevant the AI actually thinks they are. So this is like an intelligence layer being applied to your retrieval. Then finally, the final set of results from the re-ranker get passed to the generator or the response LM to give like a refined answer to the user. So some core technical specs of SFR Llama Rank was fine-tuned on top of our Llama 3 8B Instruct model. We saw that compared to industry-leading re-rankers, we achieved comparable, if not better, performance. And one thing that really is important to Salesforce is that we can have horizontally scalable enterprise deployment because we have the re-ranker and because we can manage it very closely. So that's very important for efficiency. And because we were able to fine-tune it, we were able to have linear calibrated scoring. So we could actually co-design the calibration of the re-ranking model in terms of when it ranks relevancy scores to the overall system. So that made it such that like we could actually interpret the scores in a consistent way over time. So switching gears just a little bit, tell you about one more model. It's a reward model. And so what is that? Reward models aren't perhaps in the forefront as much as other kinds of models. perhaps because they're not like always directly user facing, but they are very important and they have like very important use cases behind the scenes. And in short, a reward model is something that can predict human preferences. So oftentimes you formulate it as pairwise comparisons. So we've got response A and we've got response B, and then the model is being trained to predict, is response A better than response B? And so they're used actually as sort of like teacher models in training. So there's this thing called RLHF, reinforcement learning from human feedback, and these reward models actually generate the training signal for the models that are actually eventually going to be your assistant or your agent or whatever the case may be. In addition to being used during training, there's other use cases. They can be used for like automatic evaluation if you want to like A/B test 2 checkpoints of the same model. And I would say another use case that's really interesting is even at inference time, you can do something almost like a Monte Carlo tree search or something like that where you're sampling, and as you're sampling these trajectories of generated responses from the model, you can actually have the reward model give feedback as you're doing this and sort of prune out the low reward responses and kind of continue to generate more sampling from the high response trajectories. So I'll tell you now about SFR Judge, which is Salesforce's in-house judge model. So we have a suite of sizes that have been trained, and our 70 billion parameter version achieves state-of-the-art aggregate performance across 13 evaluation benchmarks for reward modeling. And we were able to very easily scale up our HyperPod training to this model size using 4 nodes on HyperPod distributed. And it's been very useful for us to be used, as I mentioned, for those various use cases on the previous slide. So I want to give you a little bit of what is my personal opinion about what is next at Salesforce AI. And really potentially the AI industry potentially as a whole. And I'll start by posing a few kind of questions that maybe set the stage for what we might be thinking about as happening in AI research into the next year. So are we hitting the entropy rate of the internet corpus? So that's kind of a fancy way of saying pre-training is very large and scaled up, and in terms of tokens, you're training on trillions of tokens for pre-training. Post-training, on the other hand, is what happens after you pre-train, and that is what takes you from a base model to an instruct or chat model, and then that's what takes you from an instruct or chat model to like a domain-specific model. And in this post-training, generally speaking, the amount of tokens you train on might be in the billions. And so will that scale up? I think there's some problems, which is like we need to find the data here. Maybe synthetic data from LLMs will help. Maybe mass scale human annotation will continue to grow and occur to help scale up post-training. It remains to be seen, but I think that's something that's interesting to think about. And I think very related to this question of post-training, in fact, a new form of post-training is almost what we're starting to see now with inference time compute. There's this new class of LLM. We kind of think of them as reasoning models that have recently been coming out both in closed and open source. And there is a whole new post-training process that goes into play that takes you from a pre-trained base model to a reasoning model. And how much compute and how much effort and data goes into that, I'm sure is going to continue to grow. And we will see 2025 may be the year of scaled inference time scaling. I think for now, most inference time kind of reasoning models might be able to think on the order of a minute or two. Maybe in 2025, we'll see models that are able to coherently think for hours or maybe days. It remains to be seen, but I think it's something very exciting to think about. And I think if you zoom out, what does that mean for AI agents as they start to become more and more important in the enterprise? I think you can kind of think of the overall the overall landscape as this within this lens of a multi-agent system. So we have some AI models that are specialized for some tasks, something like a re-ranker or a reward model, perhaps something like Exgen sales. So I call these components. They're almost like intelligent neural I/O. Like they have input, they compute an output. It's kind of like the same function, but it's not like a deterministic function. It's a function that requires intelligence, let's say. So they're kind of smart components. Then we have assistants. And this is essentially what most of us are familiar with interacting with like maybe Claude or ChatGPT or Agentforce. If you've chatted with Agentforce, it's something that is interactive, low latency, real time. Increasingly, we're seeing multimodal with voice and image. It might be integrated with a RAG system like SFR RAG. And I think we're going to continue to see growth and improvement in assistants, especially in how they're able to kind of connect and interact with humans and really dispatch, essentially call out and connect humans to what I imagine will be a long-running AI that are going to be running long-term processes that could take minutes, hours, or even days. They're going to be using a lot of tools. They're going to be checking their own work, and hopefully that we're going to see improvements in reliability and ability to basically produce complex reasoning that, as I mentioned, stays coherent. I think that there's a lot of push and thought around this reasoning style of LLMs that is coming up. And so with that, I will invite Anirudh to come to wrap it up for us.
Thank you, Tony. So folks, this morning, you joined us and we covered the complexities of the distributed training stack. We walked through essentially how the stack looks beginning at the accelerator device and walking right up to the HyperPod recipes. And the key idea is that across different layers of the stack, there are opportunities for optimizing the best performance on SageMaker HyperPod. And that's what our team here has helped do. Essentially, with the HyperPod recipes, we package up all of these optimizations for you, and you can easily get started here. That being said, this concludes our session. Thank you so much. Please do take the post-session survey, and we'll be around here if you have any questions. Looking forward to interacting with you. Thank you.